Hello, everyone. So we have last presentation for today. I'll try to go fast, not to hold you for long. And today, you've heard a lot about what you should do. So to give you some contrast, I will talk about things you should not do. And my name is Julian. I work for a San Francisco startup called LendUp that is providing the underbanked population of US with access to credit. And you can find my rumblings on that Twitter handle. Greenfield Effect. So we have, what we see here is this young fellow who wants to be a programmer, and he's just starting his journey to programming. And he got a job working on a legacy code base of certain complexity, and they feel a little bit confused with and overwhelmed with the complexity that they are facing. But they are inquisitive. They want to discover and understand what they're working on. And once they learn of the situation of the system they're in, this is basically the facial expression they're making. So what people do when they are a bit demotivated, in such a case, they go to a conference, they go to Infoshare and learn about all the cool new technologies, programming paradigms, and they're like, no, screw this. I don't want to work where I'm at anymore. I want to write fresh code. I want to work on Greenfield projects, and so they do. And they start the cycle all over again, because other people will have to work on those crappy code bases that that person develops. Now, the question is, why is it bad? And I will use this little pictogram to denote a brownfield project, which means a project of certain complexity, a legacy project that that is hard to understand. Now, if you apply a Greenfield effect to that project, you can immediately see this exponential nature of the problem, because the more Greenfield effects are in place, the more overly complex, flaky systems are produced. Now, why is it bad? Again, so you can identify a few terms that are related to that. There's, of course, lots of lost money because people are not working on things that are productive, but are just fixing bugs and maintaining the code base. The advancement of technology is slowed down by this effect. We, as engineers, become miserable, suffer depression. I know people who left the profession because of this. There's starting to be some, negative PR around our whole profession, and this may lead to bugs in systems that cause fatal accidents. And just to prove the point, this is Therac 25, medical radiation treatment device that has exposed a few of its patients to radiation doses that exceeded the safety norm by 100 times. And this has been caused by a race condition in the code base. While this spectacular firework that you see here, some of you might know, is an explosion of Ariane 5 rocket that happened some time ago, and that was caused by the fact that somebody tried to cast float to integer in an unsafe manner. This has caused the loss of $370 million. Fortunately, the payload of this rocket was just a satellite, no human lives lost. But these are just a few examples, and the list goes on and on. So this really indicates that we do have a problem in our industry. Now, I heard that too many times, and this is a problem because there's too simplistic understanding of how software engineering works. It's not just a machine that produces, it's not a mechanism that produces software. It's actually a knowledge crunching process, which is a way more complex. So let's, a quick entrepreneurship 101. 99% of startups hack something, release it, and then tank because they don't have any traction. While the other 1% actually makes money out of this process. So what's left to do? But scale it, and scale it indefinitely. And theoretically, that would be just a factory of money. But we all know that this is what happens after some short or long time, depending on how well the project is designed. So the cycle between the idea and shipping the product to the clients gets longer and longer. And this is very frustrating for the business because they don't really know what's happening. And it is hard for us to explain that too. Now, why do we allow this effect? It's usually because its symptoms stay unnoticed for a long time. And when we realize in what a poor shape our architecture, our technology is, it's usually too late, and it requires very serious action. So let's go through certain patterns, or rather antipatterns, that lead to this miserable situation. And the first topic I want to discuss is technical debt. This is something that we all use as a metaphor to explain to the business why there is a need to improve, to fix our technology. The problem with that is this metaphor relates to a financial or monetary debt, which is fully quantifiable, while, as we all know, technical debt is not quantifiable at all. And we can argue there are certain metrics that could be heuristics for technical debt, but really there is no single number that you can put by it. And hence, no one really decides to produce technical debt. It is just produced. Now, what is the solution to that? Well, first of all, if you are lucky enough to be on a Greenfield project and start from scratch, really focus on writing clean code, having clean architecture, and do not use this metaphor at all. While if you are not lucky enough, and you are working on a legacy system, then I would advise measure a lot about the complexity of your system before you start talking to the business. But use these numbers only to get a buy-in, but not treat them too seriously, because no one fixes technical debt by just increasing code coverage. Another pattern that I have observed, it's especially popular in San Francisco Bay Area, this talk about mythical 10x developer, an engineer who can deliver, whose productivity is 10 times its peers. But this is what I really think a 10x developer looks like, because their productivity is thanks to the fact that 10x developers never complete the tasks, and others have to do it for them. They introduce technical debt, they introduce bugs, and they do not follow up in production. All that activities others have to do for them, and hence there is this perception that these people are more productive. And here this is, there's a very important message to the business. Please never measure productivity of individuals. Focus on teams, focus on knowledge sharing, focus on instituting, forcing learning in your organization. Focus on your processes. What does it mean that something is done? Call out bad practices. Do a lot of pair programming, and you probably know what a bus factor is, but I'll just recall that there's this metric, a number of people that have to be hit by a bus in order to bring the project to stale. Try to keep it as high as possible. Have redundancy. Now, quick advice for the engineers on how to become a 9x developer. So if we assume this parity rule where 90% of the work takes 10% time to do, just identify this work, do only that, and you'll be 9 times more productive than others. But I don't know how to be a 10x developer, plus this is sarcastic if someone didn't get it. The next anti-pattern, a good reader. A good reader is an engineer who, when faced with code like that, they will read it. They will not have any opinion about its structure, and they will implement a new feature by adding another if statement somewhere here. What's the problem with that? So good readers, they tend not to care what they read. They only care about intent. And they are a great cover-up for people who write bad code. This effect prevents technical debt from emerging. And for non-technical people, it makes them think that this is simple, because I have a person who just implemented one if statement and delivered a feature in one day, while the other guy said that I'll need to refactor it for a week. Obviously, we know who wins. And there's an analogy called good listener. Imagine if you're in a meeting and somebody speaks heavy jargon, and you don't understand anything of that, but you stay quiet because no one else is raising a point. You feel dumb. Keep your mouth shut. But actually, everyone in the room feels the same way. Very non-productive. So to fix that, this is simple. We need to learn to deliberately and confidently say it in public that you don't understand something. So let's try to rehearse it. Repeat after me. I don't understand. Let's try again. I don't understand. Thank you. And you really have the right to refuse reading something like that. You have the right to rewrite it. Be a whistleblower. It pays off in most of cases. Another effect is more from psychology. It's called, I called it Dunning-Kruger halo, and it's like a mix of two effects. First one is Dunning-Kruger effect, where it's been proven that for unskilled person, their perception of their skills is a lot higher than for a person who has certain level of skills in that subject. And the more you learn about something, the less you think you know about that. And that's contrary to what one would think. But that has a very negative effect in technology, if you think. Now, the halo part. So this is, let's do a quick review. Which of these software engineers would you rather hire? And each one of you might have your preferences, but if you pick one particular phase here, the answer would be wrong, because the information on that slide has no input for you to decide whether someone can do better programming. And this is called halo effect, where someone's physical attractiveness or some other traits in our profession, that might be fancy title, the eloquent way of speaking, the fact that someone wrote a book or spoke at a conference, so this is me exercising my halo, they tend to be perceived as smarter and listened to. So if you connect the two effects, you have Dunning-Kruger halo, which means that you have people who don't know what they're saying and everyone listens to them. Now the question is, what is wrong with this? And I've been faced numerous times with architects whose opinion never had to be validated. Those people were listened to without any critique. And that caused bad decisions to be picked over good ones, and also introduce a negative factor in terms of motivation, morale. And people who do not have the luck to have the halo, they might have problems with the careers. And solution here is also simple. Just try to really question everything. In technology, there's no place for mercy. And you can do it, in a gentle way, but really staying quiet is the worst thing you can do. The other one, Stockholm Syndrome, is the effect that's we can describe it in this way, that when, for example, a kidnapper and his victim stay for a long time together, the victim may develop certain sympathy towards the kidnapper, which is totally irrational. And this is how some of us may feel about our projects or our code bases, because it took us so long and it was so hard to deliver that how would we abandon it? The fallacy related to that is called sunk cost. And it means that we will tend to favor the solutions that we put our effort to deliver rather than some third-party thing. And I've seen it twice, the same situation where a company would rather use their own in-house bug tracking system that's way inferior to whatever industry offers, just because it's been developed in-house. And this is something worth remember. Code is not an asset. It's always a reliability. And the more code we have, the less we can deliver in the future. So the last effect I wanted to talk about is the hate cycle that I made up. And it's been inspired by the Gartner's hype cycle that you all know, where interest and visibility of a technology goes through these phases where it's high and then tanks a little bit because of a overvaluated expectation. So the hate cycle looks a little bit similar, but you have something called a hate trigger. It might be an influential person talking bad about certain technology or practices, and then you have 1,000 people repeating after them. So the interest in particular technology quickly goes down, and it reaches like global maximum and then plateaus. These are the titles from some blog posts that I found on the internet, and you can clearly see that there is a very negative attitude of the author toward a particular paradigm, which can be a viral hate trigger. So given that situation, I propose a couple of book titles that could be very, very popular in a near future. So make sure you follow that. But of course, there is hope, and I want us really to understand that there are general paradigms that we rather should follow than some canned prescriptions. First, try to be skeptic, try to question everything, try to follow scientific approach, and validate every assumption is a theory. Theory has to be proven. And then learn. Never assume that you know enough so you don't have to learn anymore. Because when you do that, you do start dying, literally. Do write clean code, that's obvious. And you write clean code by learning what is not clean code and not writing it at all. But also learn business. And with learning business, there's this imbalance, because we all learn technology at schools, at trainings, at conferences like this. But we rarely have the opportunity to learn business. For example, in my domain, the credit cards, there's hardly any book about infrastructure for credit cards. So this is something that you need to learn by yourself organically, or try to inspire your peers or managers to institute some learning. And there are methods for that, and I want to refer the concept of domain-driven design if you haven't heard about that, because it's a good semi-prescriptive approach on what's called knowledge crunching. So there are processes described that you can follow, like event storming, that allow you to gather information about your particular domain. And that would conclude the presentation. So I'd like to encourage everyone to think by themselves, and now you can all go for a beer. Thank you.